Hi, I'm Chunfeng. This video will be demonstrating my project, Real-Time Rolling Bearing Prognostic System on DE1-SOC. The DE1-SOC comes with an FPGA chip which integrates ARM-based hard processor system HPS. In this project, this SoC FPGA device will be used in implementing the bearing prognostic algorithm. The HPS will be controlling the main program, whereas the FPGA will perform as hardware accelerator, and in this case, to carry out the root mean square calculation on FPGA. There are several ways in transfer data between HPS and FPGA. The FIFO bridge is selected for this project. There will be two FIFOs. One will be responsible in sending data from HPS to FPGA. Another one is to transfer the root mean square from FPGA to HPS. The program starts with data reading from files in simulating the bearing vibrational data is being received by HPS. Then, the data will undergo binary scaling, as FPGA could not read floating points. The scaled data is then sent to FPGA. On FPGA, the data is squared and summing up each other until 20k data points received. And then, the accumulated data is divided by the number of sample, which is 20k, and undergoes square root to produce root mean square. Afterwards, the root mean square is sent back to HPS through FIFO, go through reverse binary scaling and ready to be used in prognostic algorithm. To establish the communication between the HPS and FPGA, C and Verilog will be used. By looking at C, this instruction is responsible to send the data to FPGA through FIFO. This while loop is responsible to receive data from FIFO. In FPGA, the platform designer from Quartus Prime is used to call the FIFOs. This is the Verilog code, which includes the data transferring function and root mean square module. The compiled Verilog code is programmed into FPGA first. Then, the Linux terminal is used to execute the program from HPS, and this is the result. This is the time taken for the FIFO to transfer data between HPS and FPGA. In short, implementing the prognostic algorithm on software-hardware architecture is proved to be worked. Thank you.